Yes, hi and hello dear friends. Welcome back once again to our channel, VAAGAI Academy of Mathematics. And this playlist is where you can find video lessons for Class 11 CBSE Applied Maths. So just in our previous session, we started with the topic Arithmetic Progression. There we saw few basics of Arithmetic Progression, what is an AP, and how we will be having the terms in an Arithmetic Progression. And also we saw some important formulas which are going to be used in order to solve the problems. So we saw two important formulas there. So the first one is to find the nth term of an arithmetic progression. That's the first formula. And second one is the sum of the first n terms, for which we have seen another formula. Actually, that sum of n terms, Sn, that itself we saw in two different versions. So they are going to be the same, but they are expressed in two different ways. That's it. So those things are what we have seen in our previous session. So if you have missed those videos, kindly see that video and come so that you will be finding this video very easily. Yes, fine. So what is going to be the objective of this session? If you see that, here we are about to solve three basic problems from arithmetic progression only. So we have seen the formulas basics there, and based on those basics, those formulas, here we are about to work out three different problems here. So yes, let's start to work them one by one. So I'm going to work them one by one, everything in this single video itself, one by one in one shot. So yes, we'll go for that. So our first question, let's go for the first question. So I'll note it. So our question number one is, find the 25th odd number and the sum of first 25 odd numbers. So the question appears to be very simple, and let's see what are all the works we need to undergo in order to solve this problem. Yes, yeah, we'll go. So find the 25th odd number. First let's try to find that one. Find the 25th odd number. So what do you mean by odd numbers? Basically we know what are odd numbers. So odd numbers, they start from 1 and then 3, 5, 7, 11, 3, 5, 7, 9, 11 and so on. These are going to be odd numbers. We know them very well. So let's write the sequence first. So odd numbers are going to be 1, 3, 5, 7, 9, 11 and so on. These are going to be the odd numbers. And if we closely observe here, it is very clear that these numbers, this sequence of numbers, they do form an arithmetic progression. Is it or not? Yes. So if you see here, see we have the number starting from 1. So our arithmetic progression, the first term, I mean a, the value of a is 1. And what's the second thing? We are worried about what is the common difference, right? Because in order to see or understand an AP, in order to form an AP, two things are very much important. One is the first term a, and the next thing is the common difference d. Is it or not? So yes, a value is 1. That's the first term. And what about the d value? So if you see here, in what way the numbers are getting increased here? Just see that. So if you see, we are adding 2 here, right? So 1 plus 2 is 3, 3 plus 2 is 5, 5 plus 2 is 7, so and so on. It is going like this. So in that case, this common difference here, I mean the difference between any two successive terms of this AP is going to be 2. So here d is 2. So the set of the sequence of odd numbers here we see is the first term is 1 and common difference is 2. That's how this arithmetic progression is derived. Yeah, fine. And what else we have to find here? We need to find the first 25th, we need to find the first 25th odd number first, and then we need to find the sum of first 25 odd numbers. So let's try to find the 25th odd number. So what is going to be the first, the 25th odd number here? So if we continue the sequence, what number that comes as the 25th term, that is going to be the 25th odd number. Is it or not? So in that case, we have to see what is the 25th term of this AP. So I know term 25 is equal to, just remember the formula that we have seen to find Tn. Tn is equal to a plus n minus 1 into d. Is it or not? So in that case, T25 is going to be a plus, here n value is 25. So in that case, 25 minus 1, which is going to be 24 into d. This is going to be the 25th term. That's it, right? So now we very well know the values of a and d. Let's substitute it. So we will be getting 1 plus 24 into 2. That's going to be 1 plus 48, which is going to be 49. So that means the 25th odd number is going to be 49. Very simple. And now we have to find the sum of first 25 odd numbers also. That is also our next part of the question. So in order to find that, we need to remember the formula of Sn. So let's try to recall the formula. Sn is going to be n by 2 into 2a plus n minus 1 into d. So actually this is one version of the formula. So let's try to work out and get the answer through this formula. So let's see what happens. So this is equal to, what is our n value? N is going to be the number of terms. So we know that there are 25 terms here. So S25, we need to find 25 terms, right? The sum of first 25 terms is what we need to find here. So in that case, S25 is going to be 25 by 2 into, what is 2a? 2a is going to be 2 into 1. So I'm writing it as 2 itself directly, plus, what is n minus 1? N minus 1 is going to be 24 because n value is 25 here. So in that case, n minus 1 is going to be 24 into, what about d? D is 2 here. So that also we know. So this is going to be 25 by 2 times of 2 plus this is going to be 48. And once again, this is going to be 25 by 2 into 50 because 2 plus 48 will give us 50. And I can cancel this 2 and 50. This is going to be exactly 25 times. So in that case, 25 into 25. The answer is going to be 625. Yes, done. That's it. So the sum of first n or first 25 odd numbers is going to be 25. 625. That's it. So yes, let's try to use the other formula also in order to get the answer. Just a verification. So Sn is going to be n by 2 into, we have seen another formula if you remember, Sn is equal to n by 2 into a plus l. Is it or not? So here when we use this formula, we'll try to use this formula, we'll be getting n by 2 which is 25 by 2. And what about this a? A is nothing but the first term which is 1. And what about this l? L is going to be the last term, is it or not? So L is the last term in the sense 25th term. Just now we got it to be 49. So this is going to be 49. So yes, so when we try to solve this, we'll be getting 25 by 2 into, once again we end up with into 50. So again, as usual, this is 25 times. So answer is 625. So this appears to be very shorter, right? So more than using this, we can use this, but provided only when we know what is the last term of our arithmetic progression, using this formula will be a better approach, right? So if we have no idea about what is the last term, we can directly go for this formula, or else if we know what is the last term, we can use this formula to get the answer. So anyways, the answer for the first question is going to be, 25th odd number is going to be answer 49. And the next one, the sum of first 25 odd numbers, that is going to be 625. And that's going to be the answer for the first question. So yes, over. So I'm just clearing the board. So because I'm going to work the second question now. So yes, I hope the first question is clear to you. So let me just erase the first question. Yes. Now going to the second question, just see what is given there in the second question. We have find the sum of. So that is, once again, we are getting a question which is based on sum of, right? So sum of in the sense, again, we are supposed to use the formula Sn. So Sn is equal to, we'll just make use of the formula n by 2 into 2a plus n minus 1 into d. Either we'll be using this formula or otherwise we'll be using the other formula which is going to be or n by 2 into a plus l, right? So whichever is suitable, we can go for that formula. Yes, fine. Anyways, we'll complete the question. Find the sum of all 3-digit numbers. Just remember, sum of all 3-digit numbers which are multiples of 11. This is going to be the question. So we need to find the sum of all 3-digit numbers, and that too very clearly they are asking us to get the sum of all 3-digit numbers which are multiples of 11. So 11's multiples we have to take, and that too only 3-digit numbers we have to take. So this is going to be the question. So let's just think of what is going to be the first 3-digit number, that's a multiple of 11, and what is going to be the last 3-digit number, that is going to be a multiple of 11. So this would help us to get the answer in a better way, right? This would complete half the problem, so we can get a clear idea, because we'll be coming to know about the range of numbers. So which numbers will be falling under this category. To know that only, we'll just think of what is going to be the first 3-digit number, that's a multiple of 11. So it's easy for us to say, right? Because we know clearly 11 tables. So when we see 11 tables, 11 8s are 88, 11 9s are 99, 11 10s are 110, and that is where we are getting the first 3-digit number, that's a multiple of 11. So I'm starting with 110, that's the first 3-digit number. And what is going to be the next 3-digit number? It's going to be 11 11s are, right? So 11 11s are 121, or in other words, what I can say is I can just add 11 with this. So 110 plus 11 would give us 121. And what is the next number? This plus 11, that is going to be 132, and so on. This list will be going like this. We'll be having this sequence of numbers. And what about the last number? What is going to be the last 3-digit number? That is a multiple of 11. That we have to think, right? So to get the answer for this question, let's try to work a small trick. So we need to find the last 3-digit number, I mean the greatest 3-digit number, which is the multiple of 11. So we'll go for the biggest or the greatest 3-digit number itself, right? Okay, so I'm going to take this space. Let me take this space. I know that the the greatest 3-digit number is 999. So let me do a thing. I need to find a multiple of 11 which is going to be just less than this. That's my objective, right? It should be less than this 999, or it can be even equal to 999. No problem with that. So for that reason, let me divide this 999 by 11. So once I try this, I'll be getting 11 9s are 99, and in that case I can even do 11 90s are 990. So I'll be ending up with the remainder 9, right? So we are getting a remainder 9. In that case, I can just subtract this 9 from this 999. So 999 minus 9 will give me exactly 990. So what is the meaning of this is, when I try to divide 999 by 11, so we have 999 as 9 excess from a multiple of 11. That is, a multiple of 11 is 9 more than this. This 999 is 9 more than a multiple of 11. That's the result we can arrive. So in order to get a multiple of 11 itself, what we can do is 999. I'll take this 999. I'm just going to subtract this 9 from this. So I'll be getting 990. So in the case, the last number is going to be 990. That's it. So yes, we have clearly ending up with the last term also. And now it is the time for us to use the formula, because we have clearly a sequence of numbers, and now it's the time for us to use the formulas. And even before using the formulas, we should be very clear with what are all the values we have in the formula, because we need to substitute the values, right? So for which we need to be clear with what are all the values here. So this is an AP here. So no doubt it is an AP, because we have the first term to be equal to 110. So A value is 110. And what about that value of D? D, it's again simple to say, it's going to be 11, right? So it's going to be 11. And what about the value of L? Because we even know the last value. So this is going to be L, so which is 990. So it is very clear that we can even use the second formula in order to get the answer. We'll use the second formula. But again, there's a problem. We need to know the value of N. Is it or not? Because we don't know totally how many terms are here. So we need to find the value of N also. Only then we'll be able to get the answer for this question. So let me do a thing. We'll try to find the value of N separately, and using that N value, we'll try to find the answer for the question. I mean the sum of all multiples of 11, right? Okay, yes. So for which, let's use the formula itself. So we'll use the Tn formula itself. Tn is here Tn. So Tn formula we very well know, A plus n minus 1 into D. So I know that Tn value is 990, because I know the last term is 990. So this 990 will be equal to A, I mean 110 plus n minus 1 into 11, right? So this we can clearly say here. So in that case, 11 times of n minus 1 will be equal to, I can just bring this one here. So 990 minus 110 will give me 880. And so now I will be getting n minus 1 is equal to 880 by 11, which will be equal to exactly 80, and n is equal to 81. Finished. So our value of n is going to be 81. So that means there are totally 81 terms here. So we can be very sure with the value of n. There are 81 terms. So that means we are about to find the sum of 81 terms of this AP. That is starting from this 110, ending with this 990, and with a common difference of 11, I am going to find the sum of all these 81 terms here. That's going to be my objective, and once I do that, I will be getting the answer for my question. So yes, we'll try to do that. So for which I have to take the value of, the formula for Sn. Sn, as I told, we can use the second formula. So Sn is here equal to n, that is 81 by 2. So n by 2 is 81 by 2 into A plus L. So our A value is 110 plus L value is 990. So this is going to be A plus L. So that means we'll be ending up with 81 by 2 into what is 110 plus 990. So we need to add the value. So definitely it's going to be 0, 0. And what is 11 plus 99? We'll be getting 110. So 1100. Is it or not? So we are getting the answer to be 110 plus 990, which is going to be 1100. We'll even check it. Yeah, it's clear. So 81 by 2 into 1100. So when we cancel it, we'll be getting 550. So we'll be getting our answer when we multiply 81 times of 550. That's it. So for which I'm going to do one thing, 81 into 55. Let me just try to multiply 81 into 55. So 81 times of 55 will give me, so first of all 81 times of 50 will be, 81 times of 50 is going to be 4050, if I'm right. Yes, yeah, no doubt, 4050. And if I try to multiply with another 5, I'll be getting 405. That's simple for us to understand. So it will be 4455. And now it's very clear, because if I want to multiply by 550, I'll be having one more 0, so I'll be getting 44550. If you want, you can even check it. So what I've done here is I've just multiplied 81 times of 50, with which I'm adding 81 times of 5, so that I'll be getting 4485. And this is what is the answer for 81 times of 55. And if I want to find the value of 81 times of 550, I should add one more 0, and that's what I've done here. So 44,550 is going to be the answer for our second question. So I hope this question is also clear to you. It's again a very brilliant problem from arithmetic progression. So we are asked to find all the sum of all 3-digit numbers which are multiples of 11. So we should be very much clear with 3-digit numbers which are multiples of 11. So we are starting from 110 ending with 990, and first of all we are finding how many terms are there, and after that we are just finding the sum of n terms using the formulas. Okay, yes, fine. So I hope the second question is also clear to you. Before that, let me just note down the answer. So it's going to be 44,550 for the second question. Yes, and we have one more problem, last one. So I'm just clearing the board here. I want the full board here. So yes, I hope it is clear. So I can just erase it, right? Yes, yeah, thank you. So I'm just erasing this problem. So we have one last problem here. So there again we are given a sequence of numbers. Let's just have a view there. So we have a sequence 4, 10, 16, 22 and so on. It's going like that. So if you keenly observe, we can conclude that no doubt it's an arithmetic progression, right? So yes. So here question number 3, we have 4, 10, 16, 22 and so on. We have an arithmetic progression which is value of A is 4 and value of D is, no doubt, we have numbers added with 6, because 10 minus 4 is 6, 16 minus 10 is 6, 22 minus 16 is 6. So everywhere it is going to be 6 only. So we have an arithmetic progression where A is 4 and D is 6. Okay, let's see what is the question. How many terms of this above arithmetic progression will take the sum up to 690? So here we are asked to find the number of terms. We are given the value of the sum of the terms. I mean, we know the value of Sn. Sn we know here. So I'll also note it that. So Sn we know the value, sum of terms to 690. So that means the value of Sn is what is 690, and we are supposed to find the value of how many terms? I mean the number of terms here. This n value is what we are supposed to find here. So let's try to work out and get the answer for what is the value of n. Simple again. So we are supposed to use the formula for Sn. So Sn formula, we'll just recall it. So Sn is equal to, so here since we don't have any idea about what is the last term, nothing to worry, we can use the first formula. So Sn is equal to n by 2 times of 2a plus n minus 1 into d. Let's try to use this formula, right? Because we know what is the value of a and what is n and what is Sn also. So let's try to use it. So if we do so, we'll be getting 690 is equal to n by 2 into 2a. 2a will be nothing but 8 plus n minus 1 into d. So d we know that it's 6. So 6 into n minus 1. Yeah, fine. So n by 2 into here. If I do that, I'll be getting it to be 8 plus 6n minus 6. So once again, I can close it here. So once again, if I do that, I'll be getting 6n plus 2. So once again, if I take a 2 as a common factor here outside, I'll be getting n times of, if I took, just imagine what if I take a 2 as a common factor. So I'll be getting 3n plus 1 inside. So 3n plus 1, and don't worry, that 2 which we have factored out and this 2 will be getting cancelled, right? So that's the reason I'm just leaving off the 2 without, I mean not in the denominator. I'm just leaving the 2 which you see in the denominator. So I can cancel this 2 with the 2 which I have factored out. So those two 2's will get cancelled, and so that we'll be ending up with n into 3n plus 1 here. So we have clearly got an equation, so which is 690 is equal to n into 3n plus 1. So what next? So we have got an equation here. So this is like a quadratic equation, is it or not? So we are ending up with a quadratic equation. So we have no other way. We have to solve this quadratic equation in order to get the answer. So we need some extra space here. So I would have made this steps little bit in the left hand side so that we would have got enough space on the right hand side to work the problem. So yes, but anyways, there's no problem. So I hope these steps are clear to you. So I'll just erase it. I'll make some free space here so that we can work out or we can continue the steps there. So we clearly ended up with n into 3n plus 1 is equal to 690, and now we have to solve this equation in order to get the value of n. I mean, we need to solve for n and then get the value of n, and that's going to be the objective. So for which what we can do here is we have to first of all erase the board. So I'm just going to take a free space here. So let me take this space. I think this space is enough for us to work the problem. So I'll just make a mark here. So here we have got n into 3n plus 1 is equal to 690. So when we just multiply this inside, we'll be getting 3n square plus n. And once I bring this 690 to the left hand side, I'll be having minus 690 is equal to 0. So clearly we have a quadratic equation here. And once we solve this quadratic equation, we'll be getting the value of n. That's it. So yes, I think we can use the formula method. Formula method will be better, or even we can use factorization method. Nothing wrong. So it is totally our wish whether to use factorization or formula method. It is totally of our task. So I'm going with the formula method because we know the quadratic formula. What is the quadratic formula? If you want, I can even write here somewhere. Yes. So yeah, let me use a different color. So when we have a quadratic formula, ax square plus bx plus c is equal to 0. If we want to solve the value of x, x is equal to minus b plus r minus root of b square minus 4ac whole divided by 2a. That's a quadratic formula. I hope you have studied it earlier. So we will be frequently using this whenever we are ending up with a quadratic equation. That too little complicated. We can use this formula to solve the problem. So I'll use this formula here to solve it. So n is equal to b minus b. So here our value of b is plus 1. So minus b will be minus 1. So root of b square, once again minus 1 square will be 1. And minus 4ac, we have minus 4ac. So minus 4 into a into c. And that means minus 4 into a is 3 into c is minus 690. I hope it is clear to you. So the coefficients what you see here are going to be the values of a, b and c. In that case, a is 3, b is 1 and c is minus 690. That's it. So I've properly substituted the values. Whole divided by 2a. 2a is of course 2 3s are 6. So n is equal to minus 1 plus or minus root of, this is going to be 1 plus, so actually we need to multiply these values, right? So we'll be getting 690 into 12. So 690 into 12 will give you, so let's take a free space here. So we have some free space here. So 690 into 12. So what would be 690 into 12? So 690 into 12, because we will be having 4 3s are 12 and 12 times of 690 would what give us the answer for this particular step. So 690 into 12. First let me start with 69 into 12. So I'll be getting 690 plus 138. I hope it is clear to you because I've taken 69 times of 10 and 69 times of 2. I'm going to add both so that I'll be getting 28 and 1. This would be 828. So 8 would give you 690 would give you, add one more 0 here. So 8280, which plus 1 would give you 8281. I hope it is clear to you. What is done here is we have just multiplied these values which gave us 8280, 8280 and plus 1 we have here. So I'm just adding it here. So 8281 whole divided by 6. And what is root of 8281? If it is very clear to you, you can tell the answer. If you are clear or if you are very sharp in finding out square roots of numbers, that too 4-digit numbers, that too perfect squares, it's very much easy for you. So what we can do here is plus 1 plus or minus root of 8281. So I can definitely guess it, right? So we can very easily guess it. 8281, root of 8281 would be slightly more than 90, because we clearly know that 90 square is 8100, right? Because 90 square is 90 into 90, which is going to be 8100. What we have here is 8281. That is the number which is ending with 1. So sure we can say that our answer would be 91. Is it or not? So yes, it's going to be 91. If you have some doubts, you can even check it. 91 into 91 would give you 8281. Why? Because we are concluding with 91 is, we see the ending digit. Ending digit is 1, right? So any number you square which is ending with 1, the answer will also be ending with 1. That's the reason, because we know that 1 square is 1. The units place will correspond properly, right, correctly, right? So that's the reason. So it's a very small guess. I just started with the first two digits. We got 8,200 and something, so that means it should be little more than 90, and just more than 90 is going to be like 91. It's a very easy guess. If the value is going to be ending up with 4 with some other digits, what we would have guessed is it could be 92, because 2 square would end up with 4, right? So in that case, I just made it. So it is ending up with 1. So I'm going for 91. You can even go for that. You can even test it. 91 times of 91 would be 8,281. You can even guess it. Check it. So minus 1 plus or minus root of 91 whole divided by 6. Since this would give you two values for your n, we can go for only the positive value, right? Because n value cannot be negatives. Of course, after all, n value is going to be number of terms. It's going to be number of terms, and in that case, we can't have a negative value for n. In that case, we are going for only the positive value. Positive value in the sense minus 1 plus 91. So it's going to be 90 by 6. I'm going to take only the positive value, and that means n is equal to 90 by 6, which is 15. So the sum of first 15 terms of this AP would take you to the sum 690. So the answer for the third question is going to be 15 terms. So yes, I hope all the three problems that we have seen here in this session are clear to you. So they are going to be very basic things only, using those two basic formulas of what we worked out all these three problems. And if any doubts, sure, you can comment it in the comment box. And also we'll try to work more problems from the book also. And again, very soon, as early as possible, we'll try to catch it in the next session soon. Thank you so much. Bye.